What's another? Oh, here's a good one. Question 6 is a good one. Or it's incrementally more difficult than the first one. So we've got this curve y equals x cubed, and also we've got to find the area between that and this curve, y equals 4x. And at this stage, I expect that you can immediately draw both of these curves roughly. All right, this one's the cubic, so it goes up like that, something like that. That's y equals x cubed. And then this one is just a straight line with a gradient of 4, and it intersects in these places here. There's 3 points of intersection. Okay, now I'm just going to need to check the textbook to see exactly what they want us to do. Do they want us to find the entire areas, or do they want us to find just one? It looks like they want us to find the entire area bounded by these curves. Now, pretty clearly, you should be able to see that the x value there is going to be 0. But what are the x values at these 2 points? Well, to find out what the points of intersection are between two lines, we do simultaneous equations. So we have x cubed is equal to 4x. That means that x cubed minus 4x is equal to 0. And let's factorise that to start with. So we'll have x squared minus 4, x outside of x squared minus 4, and this is a difference of 2 squares. So we can have x, and it'll be x plus 2, x minus 2, and therefore the values of x that we could have would be x equals minus 2, 0, and 2. So this value here is minus 2, this is 0, as we thought it would be, and this value here is 2. And also, you should know, just through experience from earlier courses, earlier topics, that's an odd function. That's an odd function. And you should also know that that's an odd function. They're both odd functions, and they both have symmetry of rotation around the origin. So the truth is, if I just find out the area from here to there, and then double it, I'll have the entire area. So that's in fact what I'm going to do. That's why it's good to have a handle on, well, what the picture looks like and how odd functions and even functions can work to make your life easier. All right, so the area here is going to be 2 times the integral. Now, looking here, the upper function in this part is actually the straight line. The straight line 4x, y equals 4x. So the upper function minus the lower function, in this case is x cubed, and that's with respect to x, and the limits are from 0 up to 2. So from 0 to 2, so once we've done the integration, we'll have 4x squared on 2 minus x to the power of 4 on 4, from 0 to 2. And when we substitute these values in, let's see, that this will just make life a little bit easier. That cancels out there. 2 goes into 4 twice. And when we substitute these values in, we'll have 2 outside of 2 squared times 2, so that'll be 8, minus 2 to the power of 4, which is 16 on 4, which is 4, minus, it gets pretty easy from here, doesn't it? That's going to be 0 minus 0. Alright, so we'll have 2 times 4. That means the total area will be 8 units squared. The total area of this part plus this part will be 8 units squared.